Nowadays, I irritate my wife because there is someone I'm close to than her. You know who is that? My Google Assistant, who is my personal secretary, who knows everything more than my mom, my wife, or even me. Hey Google, where do I went in the evening?
I remember you told me. Evening I went to gym.
Hey Google, what is my name?
Your name is Jay.
Hey Google, how's the weather now?
Currently in Manchester it's 7 degrees and cloudy. The forecast tonight is 7 and cloudy.
Hey Google, where is my home?
Your home address is set to Manchester, CT, USA.
Okay guys, so this is just a sample of data collected by Google services about me, and it is able to provide the details whenever I ask for it. Whether it is good or bad is more philosophical and beyond the scope of this video. Obviously, we are not breaking down Sundar Pichai's congressional hearing. Our motive is to learn about what powers the short latency on search algorithms on top of such a massive data. Let's break down now. Hey guys, this is Jay Prakash. Welcome to my YouTube channel. Let's get on to the video now. In order for the cognitive AI algorithms to run efficiently, it has to be designed, the underlying data to be organized with any kind of graph technology, be it Neo4j database or any other graph database or even Spark GraphFrames, where it is recommended or it is being uh, architected to keep the data within any kind of graph technology. So in this video, we are going to get our hands dirty on the algorithms we can apply on GraphFrames, I mean the Spark GraphFrames, in order to do some predictive analytics. I'll be posting some links in the description about a concept called knowledge graph, and you must be definitely going through that and have some very good understanding on this framework invented by Google. So before continuing forward, please check out the comment section and get some good understanding about this to leverage the full power of AI over graph platforms. So let's continue from where we stopped from our previous video. And today we will see how can we apply algorithms on GraphFrames. And to be very honest with you, this video was delayed just because I want to try and provide you some hands-on experience on very large data sets. I mean, comparatively large data sets with what we have done in the last video. But unfortunately, my laptop is not able to handle that. I need to upgrade my RAM and SSD, or I need to buy some server to do it. So then decided not to delay anymore now and release this with ASAP with the small data set. So with that said, let's continue from where we stopped. So as usual, you invoke your Spark with the package needed, and we do all the initial formalities for doing Spark instantiations. So this is how my laptop reacts if I try to put pressure on it. Yes, finally it loaded. So let's copy paste whatever needed for instantiating. So this is the recap. We have a vertices and an edge. So we have done this before. So let's create a graph frame on this, both vertices and edge. So a graph frames is created as we know. And so let's continue on applying some algorithm. So what is a breadth first search? It is an algorithm that traverses a graph in a breadthward motion and uses a queue to remember to get the next vertex to start a search. So, and then when a dead end occurs in any iteration, it actually visit the adjacent unvisited vertex, mark it as visited, display it, insert in a queue, and until the queue is empty, it is going to keep on repeating it. So this is what a breadth first search is. So let's find the first, the iteration of, from Esther. Let's see who is the first user of age less than 32. So let's try to display that. See, for 5 records, it is taking some time. So from Esther, David is a friend who is less than age of 29. So that's how it finds it pretty easily without using some classic joins you do. And we can even apply some filters. So you are applying some age filter and relationship not equal to friend. So currently it is a friend, and you don't want a friend relationship, and applying some maximum path length equal to 3. So you don't want anyone more than 3. And let's execute and display what it does. So this is pretty different. So you know that it is not, we don't need a friend relationship. So and the next relationship that is less than 32 is Charlie, and that is the root for it. And we have set the maximum number of path length is 3, so we have 3 nodes attached. So this is the breadth first search algorithm. Let's see the next algorithm, like connected components. So compute the connected component membership of each vertex and return a graph with each vertex assigned to a component ID. So we are going to see how each of a node is connected to each other pretty easily. Five records. My laptop. This was the consent team. I definitely want to have some 1,000 records and show you, but this is not a cluster. Just one single node from my laptop resources it consumes, and this is how it behaves. But in real time, you will be having GPUs to do this. So any infrastructure, if they want to use some AI, they will definitely have GPUs and in a cluster, so it will be definitely faster. But don't assume that this is taking a lot of time. Even for 5 records, it is something, what is this? But if you could see this is how the components are connected. So this component column denotes some IDs saying that all these guys are connected to each other, but Gabby have a different component number and says that he's not connected. So let's display the vertices. Dot show. I think v dot show. Yes, I forgot that. Yes, then e dot show. So let's see why Gabby is having a different number. We don't see G at all in the relationship at all. So which is perfectly fine. The algorithm is resulting correctly. So all these guys are connected and this guy is not connected, which is fine. So let's move on to the next algorithm, like label propagation. So what is a label propagation? Within complex networks, real networks tend to have some kind of community structure. Label propagation is an algorithm for finding the communities. In comparison with other algorithms, label propagation has advantages in its running time and amount of prior information needed about the network structure. But the disadvantage is that it produces no unique solution but an aggregate of many solutions. So let's see how each of a node or in this particular cluster of data Let's try to find some communities. So this is another good algorithm. And these things can be used for some real-time use cases, but we are just playing with this data and try to understand how each algorithm behaves. And again, I said it took some time. Let's get on to a most important algorithm called as PageRank. It is the most popular and it has been invented by Google search engine. And according to Larry Page, PageRank works by counting the number and quality of links to a page to determine a rough estimate of how important a website is. The assumption is that more important websites are likely to receive more links from other websites. So, what is really good about this concept? That is, this concept can be applied to any graph type structure, be it some web pages or be it some airport nodes or even some bike stations, enterprise cars, uh, anything literally. So let's go ahead and run PageRank for your data. So let's run the PageRank with some convergence and tolerance limit set. So it assigns some unique number for each of the edge and each of the node. So this is how the page is ranked, depends upon how each of a guy is related to each other. Pretty good. And run a page rank for a fixed number of iterations. So we can control the parameters and say maximum number of iterations is 10. So let's display that. So it gives some vertices. Maybe it could be little different than the other, but it looks almost the same. 3254. Yep. So this is the most important algorithm called PageRank, and the other important stuff is the shortest path. So try to find the shortest path between two landmark vertices. Let's display that and try to understand how it behaves. So it says that from A to D, these are the distances. So pretty much today I cover only this, and maybe in the next video I'm going to take a little bit more data set and try to get a different environment. Maybe I'll look at the cloud infrastructure, someone like Databricks or even AWS, and try to get more power and some bigger data sets to explain with much better use cases. And so you know what to do. If you like or unlike the video, comment, subscribe, click the bell icon so that you get all the notifications on time. Please comment with all the queries so that will really motivate me to do much better videos. So please stay tuned for the next videos. Thank you so much. See you soon.